So let's discuss something about operations on set. Let us consider two sets to be like 1, 2, 3, 4, and another set B to be 1, 3, 4, 5. Okay, so first operation we'll discuss about unions. So union of two sets A and B is denoted by A union B is a set of all those elements which are either in A or in B or in both A and B. That is, it simply adds up the two sets. So we can have 1, 2, 3, 4, and 5. You see, all these elements are either in A or in B or in both A and B. So let's try to visualize it using a Venn diagram. Supposingly, if we have a universal set U, and this is a set A, and this is a set B. This is A and this is B. So the union of two sets will be whole of this portion. This whole is the union of the two sets. A union B. Okay. So let's discuss the other operation now. The second most important operation on sets is intersection. So intersection of two sets A and B is denoted by A intersection B. The intersection of two sets is the set of all elements which are common to both A and B. That is, A union B only contains the elements that are in both A and B. So we can write A intersection B as the elements that are in A and also in B, that are only 3 and 4. You see, 1 and 2 are only in A and 5 is only in B, while 3 and 4 are both in A and B, so are in A intersection B. Now let's see it using a Venn diagram. We have a universal set U, a set A, and a set B. So this portion, common portion, is A intersection B. Okay. So now we can have um, definitions of joint or disjoint sets. Joint or disjoint sets. Two sets are said to be joint if A intersection B is not of phi, and if A intersection B is phi, then it's disjoint. Okay, now let's move further. We have seen two operations on set, that is union and intersection. Now let's see the third operation, that is the most confusing one, that is difference. Okay, so for any sets A and B, the difference, that is, let's say A minus B, is defined as if is the set of elements uh, that are in A and not in B. Okay, the elements that are in A but not in B are elements 1, comma 2. Similarly, we can have B minus A as the set of elements that are in B but not in A. So this would contain only 5. So now you can see A minus B is not equal to B minus A. 1 and 2 are the only elements present in A which are not in B. So A minus B contains 1 and 2 only, whereas we see that B minus A is 5 because the 5 is only element which is present in B but not in A. Let's visualize it using a Venn diagram. So suppose I have a universal set U. Here is A and this is B. So this portion is A minus B, and this portion is B minus A. Okay. So now you can see the difference of two sets A minus B and B minus A is not the same. Okay. Now let's see the other one, that is symmetric difference. It's related to difference only. Symmetric difference. Symmetric difference can be denoted by A symmetric difference B. This A symmetric difference B is nothing but just the union of A minus B and B minus A. That is, it contains elements which are only in A and only in B. So the elements of A symmetric difference B will be 1, 2, 5, and you can see that using a Venn diagram, it is both of these portions. So it is like we can draw something new for it. Asymmetric difference B will be, suppose this is the universal set U. This is A, this is B, A, B. So asymmetric difference B will be all of this, that is, leaving the intersection part, the union of A and B. So that was for the reference and symmetric difference and for the operations on set. I'll see you some other time. Thank you.